Hi, and welcome back. My name is Idan, and in this section, we are planning to learn the main deployment models for cloud computing. Deployment model define, for example, where the cloud is actually located, who is managing the cloud virtual resources, who own the cloud physical infrastructure, and so on. The different deployment models provide some level of flexibility to an organization that is considering to use cloud-based services. Looking again on the National Institute of Standard and Technology definition for cloud computing, we can see below that there are actually 5 essential characteristics that were already reviewed, 3 main service models, and 4 different deployment models that are the main subject in this section. Let's overlay that on a diagram. There are several flavors of cloud deployment models. We have public, private, hybrid, and community. I guess you heard more about the public deployment model, as this is what being proposed today by the main public service provider like Amazon, Google, Microsoft, and others. Still, there is no single winning deployment that is perfect for everything. Each one of the deployment models, for example, the public or the private or the hybrid, has advantages and disadvantages. So at the end, each company or organization will choose the most relevant deployment options based on things like business requirement, meeting some internal policy or some regulation constraint related to security, maybe the availability of human resources that can actually manage and operate such infrastructure, overall budget, etc. Now, before drilling down to each deployment model, it is important to mention that the same 5 characteristics and the same 3 service models are also applicable to each deployment model, meaning we are expecting that the on-demand self-service characteristic will be available for any underlying cloud deployment options. Now let's start from the public cloud deployment model. Public cloud is probably the main deployment model when someone is speaking about cloud computing. Public cloud is a group of cloud services offered to the general public, meaning anyone with a credit card can use it. You can log in today to one of the public cloud providers by opening an account and start using a public cloud service instantly. Some of them even provide a free limited budget to play around and get familiar with the system capability, something that we'll use in later levels. The cloud infrastructure is owned and managed by the public cloud providers. They are responsible for the hardware equipment and software tools being installed in several data centers worldwide. They are managing the security of the infrastructure, all kinds of performance issue, hardware failure, and much more. 24 hours, 7 days a week. From a customer perspective, the cloud virtual resources can be provisioned and managed by the end users based on the type of services they selected. This is the basic concept of public cloud, outsourcing the organization IT infrastructure and start using new types of services. Basically, a public cloud is a multi-tenant environment. Maybe you heard that word, multi-tenant, where resources that are available, as part of the infrastructure, are shared across multiple customers. This is actually a key feature of a public cloud and even for other kind of cloud deployment. The ability to host services for multiple customers multiple business units or department or end users on the same infrastructure. In public cloud services, end users pay for usage of resources, consuming only what is needed and only when it is needed. We can basically analog that to some electricity utility company that measure the power consumption per each customer and send the bill according to the actual total consumption per a period of time. You can decide at the end to operate each electrical device in your home in specific hours, so the consumption is only measured when a device is consuming power. This is similar in the concept to public cloud, and we'll see that of course later. Taking a simple example, here we have 4 companies or 4 customers, A, B, C, and D, that are sitting on the same cloud provider. So we have total of 4 tenants. Take a look on company A, for example, the blue color. They allocated 5 virtual resources in the cloud service provider. Company B allocated 2 virtual resources, and so on. Those 4 companies can enjoy from something that is called economy of scale when such cloud service is sold to multiple organizations, okay, the A, B, C, and D, and more. All of them can benefit from the shared environment in the form of reduced cost, increased capability, better scaling options, etc. Let's say I'm owning a startup company for some mobile application. Now today I can use a public cloud service and instantly provide world-class service without investing in a complex hardware installation. I can pay only for the resources my company consumes today. Okay, it's a startup, so it's probably going to grow, allowing me to turn on more cloud resources when they are needed and also turn off resources when they are not needed. This service elasticity is quite useful capability. Now to the next question. How those public cloud service providers provide such service? I mean, to be able to provide a public cloud service on a worldwide scale, every cloud provider must deploy multiple data centers that will be connected using super fast network infrastructure. At the end, customer and companies and organizations can be located in many places, and the cloud service provider must provide a great user experience, enabling to quickly scale capacity if needed, connect from multiple locations, and so on. If you will check specifically some cloud service provider, you will see that their services are not really global yet and not available in every location worldwide. This is probably the main challenge for public cloud service provider, like the giant Amazon, AWS, Google Cloud Platform, Microsoft Azure, and others. They are investing huge amount of money to scale quickly into more locations, and that's going to be the fight for the next few years. Who can really scale up worldwide? I took a snapshot from Amazon AWS site where we can see that AWS operate in 45 availability zones within a 16 geographical region around the world. We are going to learn more about that in future levels, but basically a zone is like a data center, and region can hold, of course, several data centers. Now looking on Google Cloud Platform, they have 11 regions with 33 zones and over 100 points of presence. This is related to the network connectivity. And another example is Microsoft Azure, that is available in 36 regions around the world, with future plans to add more, six more regions. Now, this information is of course changing from time to time, and it should be checked online from the specific provider website. We already learned that in cloud computing there are three service models: software as a service, platform as a service, and infrastructure as a service. This, of course, in very high level, because under each service model we will be able to find many types of product and services being offered by a public cloud provider. Now, software as a service is pretty straightforward and well known today, so we will focus on the cloud-based services for the second two: platform as a service and infrastructure as a service. If we will take a look on the major players in the public cloud computing market, they basically offer almost the same product and services as part of their portfolio. I'm saying almost because at the end each provider is trying to differentiate his offering with additional product. Still, they have more than 80% common ground between them, and this is making sense as they are fighting on the same market segment. Let's review some of the very common products and services that are divided to the following categories. Compute. This is the allocation of virtual resources. Allocation can be done by the customer or end users, and in that case it will be called infrastructure as a service, or allocation and management of resources can be done by the provider, and then it will be called platform as a service. Next category is networking. Okay, computing resources must communicate with each other, okay, using virtual private network. Okay, similar to routers and switches that are being used to connect between devices. Also, traffic should be balanced using all kind of mechanism like load balancers. In addition to that, the public network can be connected to another private network using a module that is called VPN gateway, and so on. Storage. At the end, application running on the allocated computing and networking resources that we saw in category number 1 and category number 2, those applications will require the capability to store and manage different type of data. Okay, so this is another type of services being offered by public cloud. In addition, data should be backed up, restored, or maybe transferred to other location if needed, and so on. Databases. Almost any application today use some kind of database management system to store and query data. Okay, database can be like a relational database, NoSQL database. They can use distributed big data framework like Hadoop, and of course much more. Development tools are used to help developer to develop and release program codes much faster. Artificial intelligence, this is really science fiction, but more and more services are trying to utilize such advanced capability. And in many cases, the public cloud provides some simple abstraction layer for utilizing very complex artificial intelligence and machine learning capabilities. Public providers are even building servers that are running on a graphical processing unit, GPU, that are used for such use case. But this is just part of the list, and there are much more. In every public provider, we will be able to find additional unique products and services that are helping them to differentiate their overall offering. Let's take a quick tour over the web using Amazon, Google, and Microsoft as an example. Starting our tour with Amazon AWS, this is the site name that you see over here. And I'm going into in the menu to the product options, where I'm getting quite long list of products. But you see that they are divided to categories. I have compute, storage, database, networking and content delivery, developer tools, management tools, artificial intelligence, analytics, and so on. Many others. But under each one of them, there are specific product or services. And in just as an example, Amazon EC2, this is the classical product to create virtual machines. This is infrastructure as a service. Let's take another example from different category. So I'm going into product and database. This is the category, and I would like a relational database. So in Amazon, it's called Amazon RDS. I will click on that, get additional information. Amazon Relational Database Service. This is service RDS. And it's actually a managed database, a managed services where you can choose from 6 popular database engines and quickly set up a new database that's going to be managed by Amazon. And this is an example of platform as a service. Let's take our next example from Google Cloud. So I'm going to another website that is called Google Cloud Platform. And over there, again, I have all kind of categories. I'm going to product. And over here, with a big surprise, it's divided to almost the same categories. You have compute, storage database, networking, big data, machine learning, an API, identity and security capability, management tools, developers tools, and so on. Okay, again, a long list of products and services. Some of them are similar to Amazon and some of them are special to Google Cloud Platform. In our case, if I will compare that to Amazon, so for creating virtual machine, we have a service that is called Compute Engine in Google. If you would like to get platform as a service, you have what is called App Engine. Okay, it's written here, platform as a service. Let's take another example from different category. I will scroll down a little bit and go into machine learning. And over there, I will choose some API. Let's take Cloud Speech API. And that's a classical example how software can utilize the power of the cloud. Okay, the developers can convert audio to text. Okay, the whole brain is sitting in Google Cloud, and you just provide the audio information, and it will be translated to text. Okay, and so it's actually can recognize more than 110 language, and that's a very powerful capability that developer can use directly from their software. Also, let's quickly review also the Microsoft Azure site. That over there, I'm going into again to product category, and I'm getting all kind of options. Some of them are things that you already saw in Amazon and Google, like compute, networking, storage, web and mobile, container, database, and so on. Okay, this is a quite long list of options, and under each one of them, there are sub product, sub services. For example, under compute, we have the virtual machines options. And this is similar, for example, to Amazon EC2. If I will go into networking, so again, I have here options to create virtual networks, utilizing load balancing, creating VPN gateway, and more options. Okay. Now, just to understand, this is not a really details overview of those cloud provider capabilities. I'm going to do that in much more details in future levels, but this is just to give us some a high level understanding of what those public cloud providers are actually providing today. Moving on to the next cloud deployment option, private cloud. What is a private cloud? Okay, think about it for a second. If cloud computing as a concept is so great and useful for public cloud, okay, why not implementing the core capabilities of cloud computing in the existing private data center already owned by organization, and now we can call it private cloud. It is private because it is used by one single organization. Now, where a private cloud can be deployed? Private clouds are usually deployed on premises, meaning inside the private data center owned by the organization. Another less common option is that it can be hosted by a third-party cloud provider in their data center. In both cases, the private cloud will be deployed on a single tenant environment, okay, unlike public cloud that is a multi-tenant environment. And this is the main idea behind private cloud. So, private cloud is a cloud infrastructure operated for a single organization. It is not available to the general public like we learned about public cloud. Now, inside a specific organization can be, of course, multiple business units, departments, or end users that can use this private cloud infrastructure. Now, who should use such private clouds? Well, private clouds are good for large organizations that have significant existing data center asset and they want to move forward into cloud technologies. If you are already working in the IT industry, you may think to yourself, what's the difference between regular on-premises private data center to this new private cloud concept? And that's a good question we would like to answer. The easy or simple way to approach it is by considering private cloud as the natural evolution of traditional data centers. Many companies are already virtualizing their IT environment for several years now. Nothing new here. Virtualization provides additional cost-saving benefits as well as enhanced flexibility to ongoing new demands. And the private cloud is taking this existing virtualized infrastructure to the next level. A new level where resources can be allocated by users and application in more automated ways. For example, using a user portal to allocate resources without calling anyone from the IT department, using auto-scaling features to respond to increasing or decreasing demand. From an IT perspective, a private cloud offers the key advantages of agility, speed, and efficiency while maintaining control of sensitive workload that are running on the data center. Now let's review some of the key benefits and drawbacks of private cloud. Business agility. Private clouds enable the IT team inside an organization to be more responsive to business and to work more effectively with end users that require such IT resources. The IT can provide better service, monitor demand, and maintain control of sensitive workload and resources. From user side, user can benefit from quick access to the required capacity, and this will of course accelerate the ability to go after all kind of internal and external short-term opportunities, all kind of initiative. With a private cloud supporting self-provisioning capabilities, user can be up and running in hours or even minutes with minimal interaction with the IT team. And last thing is that moving to cloud architecture will also establish a foundation for new type of services, accelerate innovation, and promote cloud-aware application design principle for developers that are working inside the organization. Another key benefit while considering private clouds compared to public cloud is related to security. Private clouds can deliver a higher level of security and privacy. That's because private cloud is not available to the general public. Okay, it's only being used by one organization. All sensitive data is stored and handled internally and not really hosted on a third-party provider. Now, looking on this diagram, we have the inside and the outside physical and virtual security perimeter of some organization. The private cloud is located inside. Clients or user can access the private cloud within the allowed security perimeter. Outside users can access the private cloud while crossing something that's called boundary controller, like a firewall, VPN, etc. This is probably a major issue for many companies considering to migrate into public cloud. Private clouds reduce some of the regulatory risks around data ownership, privacy, and security due to the fact that this is a single tenant deployment model. Now, one important remark about that, saying that a private cloud is more secure than a public cloud is not always true. Okay, and just to give you one example, not all organizations are very good in keeping their data secured. They don't implement the needed state-of-the-art security technologies. They don't hire the best security experts. They don't monitor the system as they should, etc. On the other hand, public cloud providers will do all those things because this is their business. They will lose customers if the data and application will not be secured enough. So which options is more secured, private or cloud? As a simple exercise, think about it for a little bit more, and I will be happy to hear your personal opinion in the course dashboard. The third benefit is related to more control over the infrastructure. Okay, the organization can decide which hardware vendor to purchase, what kind of security level will be used, how many people will manage this complex infrastructure, how user will provision new services, what will be the system uptime requirement, and so on. Basically, the organization owns the infrastructure and can fully control how application will be deployed on top of that. If we will compare it to public clouds offer standardized services to a very large amount of customers, and therefore it will be more limited to special customization. Now, private clouds are typically more flexible to be customized because they are dedicated to and owned by one organization. So the ability to customize the private cloud solution is very useful to meet specific organizational requirement related to security, operational process, financial requirement, and all kind of other unique things. In simple words, we own it, so we can customize that as we want to. Capital investment. Okay, and this is related to money, of course. In public cloud, we learn that we pay recurrent cost per our usage. Okay, we use more, we pay more. It is operational expenses. Okay, it's not a yearly budget. And this is a major mind shift how organizations consume and pay for IT services. And if we'll compare that, on the left side, we have capital expenses related to private cloud, because private cloud is similar to a regular data center. You need to invest in IT infrastructure. And of course, there is also additional operational expenses to operate such a private cloud. But on the right side, in public cloud, we are shifting everything to operational expenses, okay? Because we are not managing the infrastructure anymore. We are not buying new hardware, okay? Now, some organizations are not so keen to shift capital investment to operational expenses, and that's okay. Okay, as always in life, nothing is 1 or 0. It is case by case. So by using private cloud, such organization can keep leveraging capital investment like they have done for many years using traditional data center. As always, nothing is perfect, and private clouds are not a so good solution for all cases. Let's review some of the drawbacks of private cloud. So private cloud should be planned, installed, and operate by the organization like any traditional IT data center. So there is substantial upfront money investment that is needed to build such infrastructure, and of course the ongoing operational cost for managing and maintaining such cloud system, similar to traditional data center. And this is remove the benefit of pay-as-you-go model that we have in public cloud, because end user already paid for the infrastructure whether we use it or not. Next thing is limited scalability. Let's get real for a second. Private cloud can be scaled only within the capacity of the internal shared pool of resources we decided to purchase in advance, of course. Most organizations can't really compete with public cloud providers that are building infrastructure, in a global scale. They have almost unlimited grid of computing resources that are available instantly in different geographical locations. And just as a simple example, a private cloud is not good fit for a web-based application being used by multiple users located worldwide that should scale up and down according to new traffic patterns. If you need global presence, 24 hours 7 support, some very extreme scaling capability, then public cloud-based offering may be a better choice than going into a private cloud. And the last thing that we already discussed is that in many cases, private cloud can be less secured than a public cloud service, because at the end, not all organizations are following the best practice in security, and they're not using, the best expert in the field of security or the best technologies that are available. Hybrid cloud. Okay, the cloud doesn't exist in isolation with other corporate IT investment. And no one said that an organization should or must select only one single solution: public cloud or private cloud. In reality, many organizations today leverage both public and private clouds. This is the basic concept of hybrid cloud, a cloud solution that is actually a mix of different cloud deployment that are integrated together somehow to form a combined IT infrastructure. So here in this example, we have a private cloud being managed by a company B, the blue color on the left side. In addition, this company allocated resources and services from a third-party public cloud provider. And now this is the green color on the right side. Users from company B can now utilize resources from the local private cloud and in parallel from the public cloud. And in that case, we got in yellow the hybrid cloud, a cloud that is based on multiple clouds. Most organizations that are using private clouds are likely to evolve into that direction, into such hybrid cloud model. So this model is going to be a very popular options in the future. One very useful scenario for hybrid cloud is called cloud bursting. In case of spikes in demand where users or applications require to scale computing resources that are behind the private cloud capability, they can keep scaling to the public cloud. The public cloud is acting as an extension of the organization, a data center. We can create virtual machines on demand and remove them when they are not longer needed. Looking on the following example, what you see on the left side, let's say we have a specific application workload running in the private cloud. Now, the application creates a dynamic workload based on usage patterns, and it is expected that this hybrid cloud will be able to scale up and down as needed. So on the left side, we have the application workload, okay, starting from some level, and then we have a virtual machine allocated on the private cloud on the right side. If I have the same application workload, then I don't need a new virtual machine on the private cloud. But as soon as I have growing demand on the application workload, I may need additional virtual machine in the private cloud, and this is keep growing. Now there is a limit. In my private cloud, I can provision up to 3 virtual machines, and from that point of time, I'm start using a virtual machine that is coming from the public cloud resources. Okay, I need another virtual machine. I'm allocating another one. Now it's keeping the same application workload, so I don't change anything. As soon as the workload is shrinking, then I can release one virtual machine from the public cloud and then release another virtual machine from the public cloud. See, this is a simple example, a classical example of cloud bursting in hybrid cloud, where I can use the resource in my private cloud and extend the workload into the public cloud as needed. If you remember, we have 4 different cloud deployment options, and this is option number 4, community cloud, and that's the last one. A community cloud is like collaborative effort in which the cloud infrastructure is shared between several organizations with some common concern. It can be related to security, maybe compliance requirement, the physical location of the data center, all kind of regulation constraint, etc. This is why it's called community. Community is usually a specific vertical industry. For example, here we have the government intelligence community. Okay, that's one example. Or the healthcare community. If we will take the government intelligence agencies, they are probably sharing a specific concerns, special needs, a requirement, and they cannot really use the generic public cloud service being offered to everyone from public cloud provider. They need something that is more tailored. So it is only logical that cloud provider will try to offer such tailored solution for different market segment. Still, it was very hard for me to find real market examples of community cloud. So my assumption is that this is not going to be a major deployment options in the future. To build and operate private clouds or hybrid clouds, we will need something that is called Cloud Computing Management Platform. Of course, if we are only using public cloud as a service, then this management platform will be provided by the public cloud provider. But if we would like to build something by ourselves, then we need such system. Cloud management is the management of cloud computing products and services. Such tools are used for creating virtualized pool of resources, providing a self-service portal for end users, handle resource allocation, monitor performance, tracking and billing the usage, and then you can bill internal and external users, and much more. Cloud management tools provide at the basic level the ability to manage multiple platforms and the complex IT infrastructure from a single point of reference. And then we get unified management layer. There are quite growing amount of cloud computing management platform. Some of them are commercial off-the-shelf software solution, while others are well-known and maintained open source platform. Selecting the best cloud management platform for specific cloud environment depends on all kind of things like the underlying virtualization environment that is being used, all kind of business requirement, the specific solution capability, the availability of skilled resources to manage such systems, support, and of course the cost of using a specific system. Okay, that's all for this section. I hope it was clear and interesting. As always, please use the course dashboard to ask a question or add some interesting opinion or some experience you already have. Please use the following quiz to test your understandings. Thanks for watching so far, and see you again on the next section.